There is a heavy-duty carbon brake stack in each wheel. Rotors match with keys on the inside of the wheel so they rotate together. Stators are keyed to the axle and are stationary. During braking, electrically driven pistons compress the stack and resulting friction slows the plane down. Nose landing gear has slightly smaller tires and brakes than the main landing gear and operates in a similar way, with the addition of rack and pinion steering system. Engines. The rear of the engine case or cowling houses the thrust reverser assembly, which reverses fan thrust to slow the plane down just after touchdown, reducing wear to the other landing parts and allowing shorter landing distance. The cowling exterior is a translating sleeve that moves backwards, pulling a ring of connected flaps into an angled position to block and reverse the normal path of thrust. APU, Auxiliary Power Unit. The APU is a backup power source that can supply energy to the things like cabin air conditioning, cockpit avionics, and so on. When the plane is grounded and not yet connected to an airport power source, the APU also provides power to the main engines for starting. Pressurized air from the APU turns a small turbine device at the engine, which rotates the main gearbox and engine internals, starting the airflow process on which jet engines function. The APU itself is a gas generator that runs on principles similar to the core of jet engine. The APU has an electric backup powered starter. Air is drawn in port at the rear of the plane. It's mixed with fuel and ignited, and the resulting combustion drives a turbine to pressurize more air for various purposes or run an electric generator. The APU exhausts out the back of the plane. Fuel. The center box and the most of the internal wing area form a giant system of fuel tanks. The main containers are the left, center and the right fuel tanks. This plane can hold a maximum of 5,681 gallons of fuel. Structure become baffles with cutouts that let the fuel travel through the tank but also avoid excessive sloshing. Fuel enters through a port in one wing. A refuel panel in the wing to body fairing controls the fueling process and also shows fuel levels. Shut-off valve automatically opening close to ensure tanks are evenly filled. To greatly reduce fire risk, normal air in fuel tanks is replaced with nitrogen-rich air after refueling is complete. Bleed air valves in the main engines siphon off pressurized air, which is then cooled and passed through an air separation module to remove some of the oxygens, leaving a more nitrogen-rich product, which is then pumped into the fuel tanks. Surge tanks at the end of each wing act as vents for the main and center tanks and have a NACA-style scoop that forces air into the tanks during flight, keeping positive pressure on the fuel system while allowing pressure changes depending on the elevation of the plane and temperature of the fuel. This scoops also allows air to escape from the system. One-way flapper valves allow fuel to flow in one direction, main tanks, but not in reverse. The main fuel pump is located inside the jet engine casing, attached to a gearbox which is powered by jet engine.